Hi, welcome to everyone's favourite segment, Mailbag. Yes, we haven't done one in a while, so let's get to it. This one is from No Starch Press. They've had several sucks of the sav here on the EEVblog. I don't need this, because it's got a pull tab. Yes, so we know what's in here from No Starch Press. Oh, now I've got to use this. There we go. Alright, well, it's thick. Yes, this is the Tvec envelope stuff. Really tough stuff. Anyway, the Arduino Inventors Guide. Learn electronics by making 10 awesome projects. Let's have a quick check. Alright, let's have a look at the Arduino Inventors Guide. It's actually by SparkFun, so I assume that Brian and Derek work for SparkFun. And there you go. Brian was a school physics teacher with an affinity for robotics. Derek is a middle school technology teacher obsessed with pushing the limits, etc. And there you go. Let's have a squiz. It's basically a project-based book. So they go through 10 different projects. And by the way, the book is $29.95 Yankee bucks and includes the digital one as well. And the index is quite comprehensive. Each individual project, wow, I mean, it's, it's 330 odd, 310 pages long. So let's take a look. I mean, we'll just show you. We'll just jump through to project 10, shall we? They're all going to be very similar materials and stuff like that. Lots of very good photos. What is a membrane potentiometer? Look at that. Piezo buzzers. Build in the circuit. We've got our requisite breadboard interface to Arduino type thing. Programming, testing. We've got some code. There we go. Got some Arduino code. What you get in the console. And creating specific notes. Not a huge amount of detail on, like, it's just mainly, programming with the Arduino, bit on soldering, things like that. So flicking through, it's like, yeah, there's some Arduino code and stuff like that. They do mention a couple of, like electronic concepts and things like that. But it's basically just how to wire up the pre-programmed, made kits and stuff like that and getting them going step by step, which is fine, but it's not something that you would want if you want to learn electronics or something like that. It's just, how to build these particular projects. So there's not a huge amount of value in there unless you're actually building the projects. So there you go. It's a fine book. They've put a lot of work into it. It's very nicely produced, as you expect from No Starch Press, but yeah, it's not, but you've got to pony. You can't just buy the book. It's pretty useless on its own. You've got to pony up for the projects as well. But that's another quality No Starch Press book. And if you want to check it out, link down below. Thank you very much, Lee Sang, Silent Eye, maybe from Singapore. Hi to all my Singaporean viewers. I love Singapore. It's it's my favourite Asian stopover destination on the way, because if you go, there's only like 2 directions out of Australia, and if you go one way, you got to go Asia. Basically, well, if you're heading to Europe, you've got to go Asia. So thank you very much. I like the feel of this, because it's obviously going to be a PCB, and yes, it is. Oh, programmable timer switch. Geez, that's sizable, isn't it? So Lee is from Malaysia, big fan. Thank you very much. Working on small projects involving some PICs. It acts as a timer switch. Just finished the PCB, which I wish we could take a look at. This is the first time designing circuits. I'm not really sure if the selected components and their values are suitable, especially the decoupling and switch decoupling capacitors. Correct if you find any mistakes on the layout. Let's check it out. Alright, first up, your power supply section. You've got a series diode in there, no worries. It's better than like a back-to-back diode across here, which shorts out your supply if you get the polarity backwards. If you can afford the voltage drop, the 0.6 volts across there, or 1 volt, at like an amp or whatever, then it's better to have it in series, because if you plug it in backwards, you get no current at all, rather than just short it out. 680 mic is probably quite high for the input. You generally don't need that for just input stability on a regulator like this. Then yeah, you don't really need that. Now, as for the regulator here, the LD11175, this is a low dropout regulator, and these are less stable than your regular, like 7805 ones, for example. You need a specific type and size of output capacitance to, make it work. It's not a problem, but it's just that when you've got a 9 to 12 volt input, I wouldn't be using an LDO here. Once again, it's still going to work just fine, but I would just be using, because 5 volts out, just a traditional 7805, no worries whatsoever. And as I said, you don't need that bigger input capacitance. And the output cap, you've got the 100N, 10 mic and 4.7 mic. And I can see on the, well, there's no plus mark on there, so these are all going to be ceramic caps, and really there's no point to doing that, especially like something like the 4.7 and the 10 next to each other. They're so near to each other, they're not like an order of magnitude a decade apart. You don't really need that. So yeah, I don't know whether or not you got that from the data sheet or not, but I doubt it. Now, these could be spread across the board, of course. It's typical to put the your multi-bypass caps just on the output here instead of, I don't recommend it, but a lot of people do that. I'm guilty of it myself occasionally, but they're not spread out across the board. Here it is. They're just all three in parallel like that right on the output of the regulator, and there's just no point to that. It would have been fine with just, say, a 10 mic. If it's an LDO, it needs, 1 mic minimum output capacitance or something like that, or the single 4.7. You didn't really need the other ones. And also notice the really large loop area here that I've highlighted in green, the ground of those 3 capacitors to get back to where it actually needs to be, which is the ground pin, pin number 1 of the U1 voltage regulator there. It's got a loop all the way around C1 like that, go right back through the input, go through that little slither there, go through D6 and then up to the pin like that. And loop area is one of the big traps for young players in terms of PCB layout and, EMC and the whole, electromagnetic conformity thing. Now, I won't go into the technical details of loop area, but is one of the worst things you can do in PCB layout is to have large loop areas like this, and it's something that beginners get wrong all the time because they don't know about this sort of thing. And if you read the layout application notes, especially for switch-in regulators, are really good. If you look at almost any good data sheet for a switch-in regulator, will talk about loop area and show you example PCB layouts, how the ground return of your bypass caps must be as close as physically possible to the ground pin of your regulator device. In this case, we've got an LDO, so those 3 capacitors should have been like flipped over so that the grounds are on the bottom, and then the ground returns straight over to the pin number 1 of U1 there. Or, as I'm going to mention later, you can do via stitching in there, like heavy duty via stitching. But in this case, you didn't really need to do that. So it's important to put, in this case, at least that 10 mic is in the example application note, directly across, as close as possible, pins 1 and 2 of U1 voltage regulator. Especially for these LDOs, they can be quite susceptible to oscillation and things like that. So having a large loop area like this may cause a regulator like this to be unstable. But in this particular case, we don't have heavy loads. We're just driving a microcontroller, and it's not high frequency switching stuff. So it's most likely, with 95% certainty, going to work. But, hey, there'll be that 5% of time when you come a gutser and the thing oscillates or you get some other issue. So, yeah, loop area. Look into it. And we'll go over to the microcontroller schematic here. And the next thing I'm going to check is like the bypass caps on the micro to see if you've actually got them. And yes, you do. There we go. We've got 2 100Ns there. That's fine because we do actually have 2 different power pins here. And if we have a look over on the board, are they close? Yep, C10 and yep. So, yep, that's fine and dandy. Having those reasonably close to the power pins, you've got them a little bit away. But for this, it's not going to matter at all. The other thing I noticed about your board here is that you've used what looks like 0603 parts everywhere. Why you do that on such a, otherwise quite largely through-hole board? There's lots of other through-hole stuff, but like, I personally, I know some people are different, but I don't like going to 0603 unless I need to. On a board like this, you'd be using, much better off using 0805, even 1206s, but 0805 is generally the go. But I know a lot of people is just like their go-to thing is the 0603, and well, okay, but on a board like this I would have used larger parts. Here's something that I noticed on your layout just then. Your input cap is all the way over here. You've got your power coming in like this, going off to your input cap, and then tapping off down here to your input. And that's not what your input cap is for. Your input cap needs to be close to your input pin and not just branching off like this. You don't want to go in over to here and then coming back. If you had it over here for like for space reasons or whatever, that's fine, but then have this trace coming off here and going back to the pin like that. But as I said, you should have it closer, otherwise you've just got the inductor in series, and that's not that great. And it's going to work in this particular case, but you know, little traps like that could ruin your day later on down the track when you get something more advanced. And the other thing with this board, geez, I don't know if I can get in there and measure it, but your via holes there are absolutely tiny. What are they, like 0.4 millimeters tops, 0.3, something like that? You really don't need your vias that small, because you may pay a penalty in terms of manufacturing costs, because you might have to go to another manufacturing process to get the smaller holes, and two, it makes them not easy to like solder wires and hack and mod and things like that. And the other thing is the board, while I do like the layout, which I'll talk about in a sec, but yeah, it is physically very large, so you would have paid a lot, you know, a lot extra for a board that big. It could have been shrunk down and made smaller, but maybe there's a reason, physical reason to make it that big, in which case it's fine. But yeah, otherwise I would have tried to get the size down on that. Now, as I said, your layout's actually quite neat. You know, the traces are reasonably short, to the point. I don't know why you chose the locations you did, but okay, that's part of layout. You choose your locations for your parts first, and then you route everything, and all of your traces are quite nice. So you'll flow around like this, around into there. There's just some short ones. You've got multiple directions on here, but you've got to do that on a double-sided layout. You've got your flood fill plane all over. I don't necessarily see any via stitching, like joining these ones together. So, like, you know, it's snaking through here like this. Once again, it's not going to matter on just a timer thing like this. There's no high current stuff. There's no, you know, high frequency stuff or anything like that. It's going to work fine. But on generally speaking, yeah, you would have added, you know, vias in here to, you know, stitch these and keep the ground planes short, rather than create huge loops like going all the way around here like this and coming back like that. You would, you know, have stitching joining both sides. But as I said, it's not going to matter on a board like this. But otherwise, like for a first design, a first layout, that is excellent. Well done. As for some of your other component values, like 8.06K, you've obviously used the E96 range there. There's no need to have such precision in a simple base resistor like that. You know, so you use like E12, like an 8K2, something like that would have been fine. And your crystals are correct like this, with your traces coming in, kept short, and then your caps going down to ground, no worries. And then for your microchip MCP7940 real-time clock chip, I don't know why you've got a diode in series with the battery here. You really don't need that. The coin cell holders, like if you put them in backwards, they're going to be okay. You don't need the 1K in series or the diode there, but can see what you've tried to do in actually protecting the battery putting in. But generally, you just you don't really need those. You can hook your battery straight onto there. No worries. The reason you can do that is because the internal resistance of the coin cell is actually quite high, and you know it can't deliver like a huge amount of current to damage anything. Even if you were able to shove it in the holder back to front, it's you're generally not going to damage these types of chips. And as for your various switches here, I'm not sure Where the switch, are they on the, oh yeah, up, down, menu, okay, all that sort of jazz. Yeah, you don't need these. I don't know why you've got the 1K protection resistors in here, and yeah, probably I see why you've done the RC debounce here, but generally you shouldn't need to do the RC debounce, so pretty much all those components will be redundant. And as for the pull-up resistor, well, you can just use the pull-up resistor inside the chip, no worries. And for your relays, excellent, you've got your back EMF protection diodes, nice. So yep, for a first design, that is a bloody ripper. Good on you, Lee. Sir David Jones, thank you very much indeed. Person unknown from Parts Unknown. I just killed the stamp. I don't know where that's from. Anyway, let's check it out, see what we got. What on earth? It is a chocolate bar calculator, a Bitten Choculator. What? That's gold. Thank you, Nick. Spotted this choculator at the boot sale and thought you, if anyone would mind lifting the skirt on this old four-banger. I'd like to know the source of its unique aroma. Yeah, it does have an aroma of kind of a cross between plastic and chocolate, is all I can say. Pom in Prague. Thank you very much, Nick. It's a chocolate calculator. Wow. Point over here. 141. Oh, I heard that creak. That wasn't good, was it? Anyway, it works. It's fake solar cell. There's actually a battery in there. Well, it could be dual power, but like, yeah. Weird. Let's crack it open. Alright. We're getting in, and yeah, there's our battery. And, looks like a real solar cell. It's actually hooked up, but yeah, we've just got the membrane keypad. That's it. And do we have... This is weird. Oh, no, right. It's just like, it's going to be a chip on board on the back of there. And well, yep, that's all she wrote. Well, you know, chip on board and a membrane keypad. Whoop-de-doo. Now, I was going to guess that the chocolate smell of this thing actually, maybe because they bundled this with some chocolate in the same packet and it's like seeped into the plastic or whatnot, but I googled it and apparently they actually sold this as a chocolate scented and shaped calculator. So, like, they've infused it with a chocolate smell. Like, why do these things exist? What is, like, wrong with this planet? Like, I don't know. Maybe someone wants it, then you can get, you know, you can get fake dog poo and fart in novelty gnomes and spankometers and, oh, jeez. Hi to all my German viewers, and thank you very much, Alex Hawk. H-A-U-C-K. From which part of Germany? Rothenburg. Haven't been to Rothenburg. So let's check out. Let's see what's in here. We got a postcard from one of your latest videos. Seriously, yes, the problem with the stupid binding posts on all these. Looks like it's a plague. All of these damn electronic loads. Oh, this is awesome. Thank you very much. Oh, beautiful. There you go. Binding post to banana plug attachment. Beautiful. Now, you've seen this BK Precision electronic load before and the annoying binding posts on it. Yeah, they're great if you've got the huge lugs to put on there. But if you just want to plug some banana plugs in, like they got no hole in there on the end to plug the banana plugs in, they got no hole in the side of the thread so that you can put your wire through and then screw it on. No, it's just got the stupid lugs. So thank you very much, Alex. I think somebody else was going to send me one of these too, but they never actually got around with it. And it's just a simple board which goes over the terminals. There we go. Look at that. They've taken off some of the code in there just to get some extra current handling capability. Not that it's going to make a huge amount of difference, but that is very, very nice. A very nice, solid, insulated binding banana plugs, and it just goes over there like that. Beautiful. It makes contact on the top side and the bottom side, of course. Fantastic. So that is an absolute winner, and I'm going to leave that permanently connected because I'll probably use it 95% of the time instead of the binding posts. And they've got the banana plugs coming out the right way, because you want the cables coming out this way instead of, if they were coming out this way, then it'd be over the buttons. If you had them coming out the top, it'd get in the way of that. You could have them coming out the front, I guess, but then it'd get in the way of turning these, so that's ideal. Perfect. Unfortunately, it's not the same for the Rigol one, which has the same issue with these stupid things. Anyway, I should be able to fix that by just drilling another hole in the side there and scraping off some of the solder mask there and on the bottom, and that'll work a treat. So, yeah, what do they do? Like, copy each other's, like, crap design binding posts? I don't get it. Another suck of the sav from Germany, from Person Unknown. Thank you very much, Person Unknown. Let's chop the note. Whoa, there's something in here? What? It's a switch. Why do we have a PCB mount switch? Hi Dave, I've had this for some years but never got around to sending it. In one of your videos you mentioned you broke the power switch of your Rigol DS. Oh, 1052, I did the same while changing the fan in mine. Oh, thank you very much. I tracked down the supplier in China, well done, and got a few replacement switches, so have one. Awesome, thank you very much. Yes, I did break my, busted my Rigol, original Rigol DS1052E. That's at home now, so I won't be able to show you that. That's like Sagan's oscilloscope. He plays with that. And great, thanks. Awesome, replacement switch. Winner. No drugs, because, well, yeah, we do have pretty strict customs here. They won't muck around. No drugs, only an electronic USB chip to the value of 0.1 cents. Thank you very much from somebody from Lars in Norway. Hi to all my Norwegian viewers. How's it hanging in Norway? Or grid paper. Nice. What do we got? We've got a tiny look in the microscope. Okay. We've got a tiny little board. Thank you very much. Still Person Unknown with beautiful penmanship. Look at that. Look at that. Fantastic. Like, it's not, you know, like, I just like it. It's not your classic penmanship, but it's almost, it's beautiful. They're all the correct height and everything. It's wonderful. Excellent. Unfortunately, stop stick only an MPEG4, world's smallest TV dongle. From Sandburz.it. Italian. Okay, we'll have a quick squeeze under the microscope. So there you go, the world's smallest TV DAB FM receiver that plugs into the USB. No, it doesn't. It used to have a USB plug on it, I think. But yeah, it's tiny. Just antenna connector on input, and yeah, let's check it out. I'll get the macro lens. And there's the top side. It looks like we've just got mostly regulator stuff. You can tell just by the bypass caps and the typical 5-pin SOT23s that'll do the business. And what do we got? A couple of chippies on the bottom. That's it. Geez, there's not much doing, is there? And that puppy there is a Realtek RTL 2832, and that's just a USB input DV receiver. It's like all the magic. Smoke is in one chip. And the other one, right next to the antenna, dead giveaway, is the RF tuner. It's an Elonix E4000, and apparently these were the duck's guts in the SDR community, the software-defined radio community. Apparently this combination of chipsets was apparently highly regarded, but Elonix have apparently folded, and you can't get the E4000 chipset anymore. So yeah, this is an older design, but apparently a lot of people use these things for software-defined radio stuff. Cool. As for heat building up inside the rubber, I'm not sure what the casing it was, but the chipsets wouldn't take much at all. I mean, these are linear regulators on here, but like, you know, 79 milliamps and 1.5 volts for the tuner. I don't know the Realtek chipset. PDF doesn't seem to be easy to come by, probably under bloody NDA or some crap like that. But yeah, I don't think it would have consumed a huge amount, so I don't think that would have been an issue. Thank you very much, Steve Fazio, or is it Fazid? I think it's Fazio. From Geneva in New York, USA once again. Hi to all my New York viewers. Is there anyone else in Geneva? I've never heard of Geneva, New York. I've been to Geneva, Switzerland. Been there, but I haven't been to Geneva, New York, that I'm aware of anyway. Tissue. Oh, we have. Oh, nice. Look at that. Beautiful. Handcrafted. It's a solder dispenser wheel. Fantastic. There you go. Scan me. Thank you very much, Faz, who's a youngster and works on restoring scopes, among other things. These are some various scopes. His favourite is the 7834. Awesome analog storage. Ooh, fancy pantsy. And designed this little, built this handcrafted little solder dispenser. Perfect. I've only got the one here, and I've got multiple rolls of solder, so that one's going straight to the pool room. Thank you very much. It's going to work a treat. Thank you very much, Steve Kepler from Leo, Indiana. Yes, it's a Yankee Fest. I'm just picking these randomly off the... Hope it's not fragile. Anyway, is there anyone from Leo? Right. Circuit Classics. A stepped tone generator. Sweet. It's got to be a kit. We have note. We have a blank board. And nice. Oh, it's the old Forrest Mimms circuits brought back to life by, I didn't know it was Steve Kepler. It's Star Simpson, who sells these on Crowd Supply. So I'm not sure if Steve is related in some way to that, but or whether or not he just randomly sent me a kit. Anyway, they brought back the Forrest Mimms. There's like a how to solder in the Forrest Mimms kit. If you don't know, we've had Forrest on the Amp Hour podcast, which I'll link in down below. Fantastic. A couple of hours. The guy's brilliant. So yeah, let's check it out. Yes, so this is the Forrest Mimms the third, who we've had on the Amp Hour. Fantastic multi-hour interview. I'll have to link in. And this is basically his project recreated, complete with his original hand-drawn schematics, straight out of the book. Look at that, and the various notes or whatnot from the Engineer's Mini Notebook, the 555 Timer IC circuit. Page 22, and obviously there's a coin cell battery that goes on the side there, and these were done by Star Simpson, so I still don't know what Steve has to do with it, but anyway, thank you very much. And it comes with the little, the original hand-printed, hand-done Forrest Mimms how to solder thing, and this is the Circuit Classics. There's a whole collection of these, which I'll link in down below. Oh, look at these, cute. Anyway, came with all the parts. That'll be a kit that Sagan and I can assemble together. Brilliant. Thank you very much, Steve. Thank you, Chris Cochran with a K from Northumberland in the UK, the old Dart. So let's have a look. From the description on this, we've had plenty of these, so I hope it's something for Dave. Oh, look, it's purple. Oh, Thought I had the open source hardware thing. It's not the key. So retro gear, well, let's check it out first. Here we go. And, yep, Sion. We have done Made in the Old Dart. People probably haven't seen all my mailbags, but we've had Sions at least 2 or 3 times. Cool. It's the Sion II Model CM, so already done a teardown, unfortunately. So yep, we've definitely seen one of these. This is the Model CM, made in the old Dart, of course. Fantastic, the Sion Organizer 2, and yes, it was one of the first usable PDAs, and these things were massively popular. I remember I lusted after these, but we have done a teardown and an extensive comparison, I think, of the various PDAs back in the day. But yeah, got processor in there. We've just got some SRAM, none of that modern DRAM rubbish. This would, and of course the program packs. You could just slide the program packs in. They just go on these 0.1 inch headers, and they had pre-programmed, expanded memory and pre-programmed apps and things like that. And these were very popular. Not huge, probably more so in the industrial market for inventory control and things like that. They were really huge. And I don't know which would have been bigger, the consumer or that industrial market, but my guess might be the industrial market in the end, because these things were built like a brick dunny. Hi to all my Austrian viewers, in particular Reinhard Grail from Ostrich in Austria, not Australia. Let's crack it open. Once again, we've had these on... Oi! That... Sweet. That is a full-on Radiosonde. We have had one of these before, but this... Vasala. We've had the Vasala Radiosonde before, but this looks like a complete intact one. The one we had before was like a real old, or much older one. It was like 20 years old or something in was it a cardboard and styrofoam box or something? This one's in a proper plastic. Geez, it weighs a bit. Because normally, if you don't know what a radiosonde is, these things are atmospheric sensors, hence all the fancy whiz-bang stuff up the top, and they... sense, temperature, pressure, altitude, all that sort of jazz, and they transmit it back to the ground. They send them up. They're basically weather balloons, and that's how they do it. They whack them on the helium balloons, and up they go, and they drift around, and they get I assume they get the location as well, and transmit it all back. Anyway, very cool. Wow. Is this worthy of a separate teardown video, perhaps? Because they're fascinating stuff. They really are. Yeah, oh, geez, it's even got a little port on it. Wow. Yeah, if you don't see this in the mailbag, it's probably because I thought it was too interesting and I decided to do a separate teardown video on it. I got the note with it. This one actually fell into Reinhard's backyard with a note attached to it saying it belonged to a weather balloon and he should be so kind as to dispose of it. So instead of disposing of it, he decided to send it straight to us, fully intact. Awesome. Yeah, these things litter the planet. They just, they send up thousands of these radio sondes probably every day and to get, weather data and stuff like that. So, fantastic. I love it. Fell into his backyard. What are the odds of falling into I've got almost 500,000 subscribers, so maybe, I don't know, can anyone calculate the odds? How many go up per day versus the square area versus, number of viewers? Thank you very much, Reinhard, who was lucky enough to have one of these land in his backyard, directly near his garden, hanging from a parachute. And I've done one before, but it was an older model. This is a newer model, which has the GPS antenna, the transmitter, all the sensors and things like that. But I'm going to save that for not only a separate teardown video, but I'm thinking it might be an EEV Discover video. If I can get the right contacts, I might be able to do some interesting stuff at this. But yeah, somebody on Twitter said they actually work for Vasala, I don't know, and how you pronounce it. And they manufacture like they said thousands of these are released per day, and they are a one-shot deal. So I'm going to leave that as a tease. Sorry. Next. And also somebody on Twitter actually converted their car into a tracking vehicle. I believe he's from South Australia, and actually tracks down these. You can actually get modelled in software to predict where these things are going to land, and then you can go and hunt them down. And it's a bit of a game, and some people out there go and hunt these things down and have a big trophy wall of all their Radiosondes. Brilliant. And you may know what this is from Zintony Ra. Thank you very much. I've done a video, was it a video? Yeah, it was a video review of the Zintony Ra backpack light, and they actually saw that. Kogala is the company, and they said they'd send. They said they liked the video and they appreciated the feedback and all that sort of stuff, and they said that they would send me some accessories for it. So thank you very much. Egyptian stuff. Cool. I'm really into Egyptian stuff. And yeah, these are like little attachment things which you can put on it, so you can put it on your backpack and whatnot. And they've sent me another battery pack. Tiny little battery pack. Oh, isn't it cute? Anyway, yeah, can't do a teardown. It's all ultrasonically welded or whatnot. But assembled in China, US patents pending. How can you have like what, a design patent for, you know, like how can you patent a just a battery pack? It has to be a design patent in terms of the look and feel kind of thing. So I think we might have a couple of more PCBs. This one's from person unknown, so let's just, I probably shouldn't have done that because it has like a note. We have a PCB. It is a smart supply. Oh, wow. Okay, cool. It's a, there you go. It's probably a variation of the micro supply somehow. Two 18650s. Neat. 0 to 20 volts, 0 to 1 amp. Sorry for ripping the letter. That's a real pain in the butt, isn't it? Jeez. Electronics engineering student from Belgium. Thank you very much, Thomas. Even though it wasn't on the... yeah, he stumbled across my micro supply project and knew he wanted to make one, only to find out after 14 episodes that you didn't finish it. Yeah, sorry. Various reasons for that. We are working on it again, actually completely from scratch. It's not based on this LT3080 design anymore. It's a smart supply. That's neat. I'm glad it worked out for you. I got quite a lot of people actually built their own variants based on the, well, my last micro supply schematic based on the LT3080. Cool. Nice work. Hi, I'm Thomas, an electronics engineering student from Belgium. Hi, I'm Dave, and I'm a dickhead for tearing your note with my big-ass knife. Anyway, he stumbled across a micro supply project. First time I saw the video, I knew we wanted to make it. After 14 episodes, we never finished. Yes, we didn't finish, but having said that, David too and I are now working on the micro supply again. It's not carrying on from where we had before, but trust us, we are working on it big time. So hopefully, we will come out with that, and videos will be posted. There's a talk I've done, there's a section on the EEVblog forum where I've shown like a custom LCD which we're going to do for it, and stuff like that, and everyone's discussing it and things like that. But apart from that, no other details. Sorry. Anyway, specifications similar, 0 to 20 volts, 0 to 1 amp, powered from 2 protected 18650 lithium cells, and it looks something like that. Isn't that neat? I can't remember what my interface looked like. It was very similar to that, wasn't it? Set and out, and put it into a funky little case, and isn't that jazzy? There you go. So I'll link it in down below. Where is it? Do we have a website somewhere? GitHub. There we go. GitHub. Thomas VDD Smart Supply. Fully fledged open source hardware logo. Excellent. Hasn't got my letters on there though. So that looks pretty jazzy, doesn't it? I like it. Cool bananas. There you go. A lot of people have done micro supply type variants of the project, and I totally encourage it. It's great to see. Yeah, there's lots of people on the forum who've, you know, done that sort of stuff. I like how it's almost all through hole, except for that puppy up there. But anyway, that looks like a nice layout. Jazzy. There's inside the finished product, and yeah, we've got the using the back panel as the heatsink in time-honoured tradition, and it looks like it uses the LT3080 still. So there you go. So well done, Thomas. That's an excellent implementation. Linked in down below. It's all open sourcey. Hi to all my Finnish viewers. This one's from Julius Willuko from Espoo. Espoo in Finland. There you go. Let's have a squares. I believe this one is a PCB. Feels like a PCB. It's always a dead giveaway. Hi Dave, this is Mystery PCB. Can you guess what it does and what its electrical function is? Thank you, Julius Wilho from Finland. The answer is in this second envelope. Ah, there's a second envelope. No? No? No. Can I guess the circuit function? Oh, geez, it's got two. It's like, there's no, the only traces on there are, tell the hand. Focus. The only traces on there are those two big fat ones that you can, yeah, you can see that there. There's two big fat ones. So it's some sort of, well, it's high current. So and everything else is like mechanical type interfaces. So it's like, I would say it's from some, like maybe a little robot car or something like that. It's probably got like some high current motor drive or something. It's kind of like a base, or it could be like for a quadcopter or some other, like, you know, some other base that mounts motory type things onto it. Would be my guess. Got to go to that web address to see if I'm right. Oh, bang on. I just went to check, and it's for a slot car. It's actually the bottom chassis of a slot car with the motor connection and stuff like that, like a homemade slot car. So yeah, I was bang on. It hooks up to the motors, and it's the mounting, like I said, it was a base kind of thing, and motors hooked up, and that's exactly what it was. Homemade slot car. Cool. See, wasn't that hard. Mystery PCB. Nailed it. Hang on.
That was easy.